Good afternoon. We're going to go ahead and get started because we have an action-packed educational session for you here on artificial intelligence in the clinic. My name is Dr. Debra Patt, and I'm a community oncologist, a medical oncologist at Texas Oncology. It's a pleasure to talk with you today, and I'm really moderating the session. But I wanted to help you imagine how AI will help us in the clinic. And so this is a picture of my practice throughout Texas. And I have this up here to talk about my own bias, because we're all biased by the lens through which we see the world. First and foremost, I'm a community oncologist, and I have the privilege of serving as a breast medical oncologist in this practice that has about 300 sites of service. And so that means that we have different challenges in clinical practice, whether we're urban at a cancer center with 50 doctors or rural in a cancer center with one doctor. And so all sorts of different challenges and operational opportunities that AI really helps with. And I was going to walk you through some of the things that we do and how I think about how AI is shaping cancer care more broadly, just to open us up. Then we're going to introduce everyone, and you'll see different perspectives of AI in cancer care, everything from sort of the ethical risks and opportunities to the technical aspects of large language models and generative AI, to how AI is used in the clinic, and then some question and answer, including our patient perspectives. So AI is shaping cancer care in so many ways, serving patients navigate their journey safely and easily, putting healthcare at their fingertips, managing workforce, trying to help with burnout, helping our clinicians be more effective, managing staffing shortages, helping with efficiencies, allow people to work top of license to do more faster. There are risks that we'll talk about. And I think some of the pearls, I think for those of you that are in the room, you're probably trying to figure out what solutions you need to incorporate to change your practice and how you help your organization navigate this practice. But I'll say, in my opinion, that is the first step, but probably the easiest step, because I think that the change management and the disciplines of execution are the hardest aspects of how you incorporate some of these changes in clinical delivery. But I think that it will happen everywhere all at once, and where it works best, we probably will see it very minimally. So I want to talk about that. So AI in healthcare is growing tremendously. In the United States, we spend $4.5 trillion on healthcare. And so there's a tremendous economic opportunity. And AI in the US healthcare market has a compound annual growth rate of 36%. So that is out there to say that there's a lot of economic benefit to people going into the AI space, which means you're going to have some people that are good at it, and you're going to have some bad solutions that are pitched to you, that you meet with, that you have to realize that they're bad. And maybe they're bad because they want you to build the ship as you begin to sail it. Maybe they're not as well thought out because they have some safety issues as you think about their incorporation, but it's an important perspective to consider. In supporting the patient journey, as you probably, if you were here for the last set of talks, you'll know, we see it in screening, whether it's new CAD-enhanced mammography, colonoscopy interpretation of polyps, how we think about diagnostics with biopsy interpretation, scan prioritization, and imaging interpretation. So much potential in research, drug discovery, the great work out of Google Cloud AlphaFold with drug discovery, and how we're repurposing some drugs that have been sunsetted or that have other clinical applications to really understand what are the good agents for clinical trials, how we optimize efficient accrual of clinical trials, and how we use AI to identify eligible patients is really exciting, and I think will accelerate drug discovery in a really meaningful way. How we think about therapy selection and clinical decision support, as well as predictive analytics, therapy monitoring, how we think about patients and their therapy pivots, patient and caregiver education, which I think is a huge gap today, and then supportive care resources. I think as cancer practices, we're asked to do things that we haven't historically been asked to do around assessment of mental health, socioeconomic status, supporting financial toxicity, that AI offers us solutions to make us better. As a clinician, where I think it works better is as a nudge, and the nudge is clinical decision support. So you'll hear this as a recurring theme, that AI has some risks, but if you put it as a nudge, as you give it choice architecture, then it allows you to really, it's a facilitator of clinical decisions. It identifies eligible patients, but it isn't putting patients on trial. It identifies therapeutic opportunities, but it's not writing a prescription, right? At the end of the day, the doctor-patient relationship is sacrosanct. This is just an example of clinical decision support. This is my health record. This you can see here on the left-hand side. There are structured data elements that are introduced by the doctor. From that, there's a pop-up of sort of nodes on the decision tree of therapeutic choice, and those that are preferred are green. And so that's a way that you can foster clinical decision support. You select them in your chemotherapy regimen with your antiemetics is populated. Studied the implementation of this, and we demonstrated that across 9 statewide practices with 30,000 patients that were treated with chemotherapy, we were able to statistically significantly improve adherence to evidence-based regimens. And you can imagine that same technology for clinical trial eligibility empowered by AI. We've really used it to implement a lot of different digital tools to support care delivery, things like care management, remote monitoring with electronic patient-reported outcomes, a patient portal, and digital education. So you heard yesterday about the positive trial in metastatic breast cancer with electronic patient-reported outcomes. This is just an example of what the EPROs we have look like. So patients fill these out, and we've enrolled 70,000 patients on active chemotherapy over the last 4 years. This then is triaged to a communication architecture of nurse navigators that work remotely, and they have pathways to manage patients, which allows them to answer patient questions more quickly. That system is enabled with AI today, so it helps bring that information forward, push information out to patients and to the nurse faster, so the nurse can be a nurse, and they're not having to spend a lot of time in the administrative burden of documentation. They don't have to do what the AI says that they do, but again, it's clinical decision support. And so that's a significant way in which AI will act. Another way in reducing the work burden is in the ambient AI scribe service. So in our practice that has 600 doctors, we've onboarded 500 of them on an ambient AI scribe service. You're seeing more and more of those in the clinic. As we brought forth a solution to my partners of AI in the clinic, I really called it the Home for Dinner campaign, because we want for people to not be there with the documentation burden at the end of clinic, but really to allow that to provide some efficiencies. As we think about how we incorporate AI, I will say we do need to have some guiding principles to make sure that we're responsible. I was privileged with myself and some other people in the room to chair ASCO's task force on AI this last year, and we published some guiding principles of AI in oncology. I think this is really important. We need to make sure the things that we're doing are ethical, responsible, and don't displace the important and really critical relationship between doctors and patients today. So I look at this as a journey to nirvana, and this is an AI-generated map of a female doctor with a map, right, as you try to think about this journey to nirvana and how we incorporate digital tools to clinical practice. Our organization will need us to navigate this change. They will need us to think through how we navigate our future really thoughtfully. So I want to thank my leaders in my practice and collaborators outside of my practice for sort of helping me think through this, because I think that this is a really important way in which we're all going to have to contribute to oncology's future, and the degree to which we do that will help us be more successful. So I'd love for our panel to introduce themselves here today, and then we'll get started with everyone's talks.
Hi, good afternoon. My name is Emily Ray. I'm a breast medical oncologist at the University of North Carolina at Chapel Hill. I'm also a health services researcher interested in the development and implementation of risk stratification tools and the development of supportive care interventions to improve patient outcomes.
Hi, everyone. I'm Andrew Hantel, apart from being the one who's had the coughing fit for the last 5 minutes. I am a leukemia physician and health services researcher and medical ethicist at Dana-Faber and Harvard Med School. So hopefully I'm the only hematologic oncologist in the room.
Good afternoon, everyone. My name is Terry Crudup. I'm a 2-time breast cancer survivor. also a patient advocate working primarily with the Society for Integrative Oncology. And I also work in healthcare in my day job for Outcomes for Me, which is an award-winning and free cancer companion app that helps patients understand the NCCN guidelines, provides many tools and resources, and uses AI to drive the personalized experience for the patients. And I'm very excited to be here today to partially represent the patient voice, and I will turn it over to my fellow patient.
Hi, I'm Sandy Stanford. I'm with the Alamo Breast Cancer Foundation here in San Antonio. I'm a almost 31-year breast cancer survivor of stage 3B, and way back when, they told you how long you had to live. Just, oh, you got this long, you know, put your affairs in order. They gave me 3 years, and I'm still here. So, and part of that is by being an advocate, by learning, by being on grants, being on PCORI, being on CABS, being on like 5 grants right now. So I appreciate Virginia and Kate asking me to be on the panel. That's mine.
Hi, my name is Ian Maurer. I'm a software developer and the Chief Technology Officer of a company called Genomoncology from Cleveland, Ohio. We build solutions that help providers, whether it's molecular pathologists or oncologists, make sense of genomics data, and we use large language models for assisting in that analysis and also for doing the messy work of structuring and cleaning unstructured data that are, you know, kind of swimming in healthcare.
All right. Well, again, thanks for having me here. Disclosures, none are related to AI. So I know that, excuse me, I know that Deb already had put up some definitions of artificial intelligence and large language models and talked about them a little bit. If the people could put my presenter notes back up, that would be great. Thank you. Then I don't have to go into these too much, just to say that AI is simulating human intelligence, and large language models are a subset of AI that is trained on vast amounts of text data to really understand and process human language. But before we delve too much into kind of individual hazards and opportunities of AI, I wanted to really set the stage by thinking about how clinicians might interact with AI. And this is kind of in a broad sense, not like, oh, you might use it as a scribe or something. The first is that, you know, AI might come into practice through personal adoption. So I use AI tools daily. I've seen how they might add to my efficiency in medical practice. So at what point should I, as kind of a responsible physician, incorporate them or even be obligated to use them in different scopes of what I do? We don't think twice about using other types of technologies, stethoscope, CT scan, in diagnosis, and so why should AI be exceptional? Should it kind of meet the same bars of kind of adding to our portfolio of diagnosis, communication, treatment with patients? The second is really integration from the institutional recommendation or institutional standard even. I might think a lot of this as you know, AI scribes efficiency tools that are really multiplying faster than we can keep up with. But if our institution takes one of these tools and says, well, we're going to be putting, you know, microphones in all the clinic rooms, recording you and your patient visits, do you have the same responsibilities for thinking about it, for monitoring it? What responsibilities do your institutions have to vet the tools with you, for you, and support us when they're wrong? And vice versa, kind of what institutional responsibility exists when you start to use tools that they don't necessarily vet or recommend. From the patient standpoint, this can happen too. And so patients are increasingly using AI tools of their own accord, putting their own medical records into ChatGPT or to other tools and having them not only decipher the medical that we put into our notes that we have that they have access to now, but also helping them understand, is my doctor up to snuff? Is my doctor making treatment recommendations that others agree or disagree with, at least as kind of sifted through and decided by AI? And so this can either go right in terms of having our patients kind of become better educated, becoming more accessing essentially more amounts of data, especially for those who traditionally had lower health literacy or had less access to kind of the specialized knowledge that we do. And so it can, as multiple speakers have said in the last session, kind of improve health equity from that standpoint. And then we can just have combinations of all of these three. But AI is really not exceptional in the way that it can kind of enhance cancer care and research broadly in terms of it's trying to help us solve problems. And really the question that we should ask is that question: what tool is this AI, or excuse me, what is the problem that this AI tool I want to bring into clinic, or my institution wants to bring into clinic, or that my patient is bringing into clinic? What is it trying to help us solve? Does it improve that problem? Does it actually do it better than a non-AI solution? And like we'll go through with the rest of the talks, or rest of the talk, what kind of moral hazards, opportunities does it raise? And really with any of these questions of moral hazards, should it be held to a different standard than we hold our colleagues? How do we evaluate these things? And really what supports exist, what assurances exist for the use in a responsible way? So when we think about integrating AI into clinical care, there are myriad hazards and opportunities that arise. Some are really long-standing and AI does not put them into kind of new questions or ask us new questions about them. These include data ownership, privacy and security, and safety. There are also these kind of areas in the middle where these issues are not new by any means, but AI really asks us about these concepts in new ways. And then on the right, we have some actually kind of new hazards and opportunities that we need to think about as AI is applied into clinic. So data ownership has really been recognized as a property right since the 1960s. LLMs and other AI tools, using vast amounts of data, obviously raise concerns over who owns those data. These are already causing a bunch of legal issues. I think that one of the most prominent is kind of the hundreds of people that have sued OpenAI for scraping their data, the New York Times, many authors. And from a clinical standpoint, which is poised to have AI bots listening to us into clinic, writing clinic notes, processing conversations, images, labs, we have this concern that patients will be even less and less understanding of where their data live, who owns them, and how it is being stewarded. Now, while these concerns about ownership are not new and have always been of concern for clinical practice, the two main ways that AI might impact these kind of related areas of privacy and security are really putting together disparate data sources for making predictions about somebody's health, and how AI might drastically lower the bar for re-identifiability. Clinically, we now consider a number of discrete data points for treatment decision-making and patient recommendations, stage, molecular subtypes, a number of labs. General and generative AI models trained on really a world's worth of data, however, have access to different types of data about somebody than we do. Their search histories, their locations, their shopping preferences, other factors. This may lead to more, I would say, interesting and potentially more tailored recommendations for patients. We could have an AI recognizing that a patient with recently resected lung cancer is living or visiting a place that's going to have upcoming wildfire smoke. And there's emerging data that wildfire smoke exposure after resected lung cancer increases mortality. So you could in the room and the AI just suddenly says, oh, you should probably have your patient wear an N95 for the next 2 weeks. That would be a pretty off-the-wall suggestion if we didn't know where the data was coming from, how it was correlating it with other things that the patient had done, such as like booking a trip to California, those kind of things. But it also leads to potentially a lot more nuanced recommendations for patients and kind of how they're living outside clinic, which we often, to the best of our ability, don't have the ability to capture all of the things patients do in their lives. On the other hand, it could also have incomplete data about, let's say, prescription refills, think that a patient has a history of not filling a prescription rather than just not having access to those data, and because of that, think the patient is not compliant and errantly recommend against an oral therapy. On the other hand, we have this issue of re-identifiability, and this isn't a new issue per se. As I said, these are the old issues, but I think just AI lowers the bar for re-identifiability much, much more than we've had in the past. In the past, with the idea of HIPAA and access to medical records, the actual effort that would be needed to re-identify somebody through redacted records and things, even if they're posted in kind of one of these large biorepositories, is exceedingly low if you have to do it without AI. But with AI, it actually makes that a possibility and something that really needs to be thought about. Now, when we turn to patient safety, our last set of old news, we can think about AI-related issues in two buckets. One, kind of what are these processes of safety that AI might impact, and two, what are categories of safety? In terms of processes, we have issues that if there's not really adequate explainability in an AI tool for how it arrives at a recommendation, we might not know when things are going wrong, might not be able to recognize them, and have need for new mechanisms for doing so. We also know that there are rampant medical errors in the United States, and AI's ability to churn through unstructured data means that, on the other hand, we have a new and powerful tool to help us recognize when we have not considered some important drug-drug interaction, allergy, or obscurely written intolerance in the medical record that might make things less safe for a patient. And then we have these categories of safety, which I lump into things intrinsic to AI devices, like the inputs, its decision-making or outputs, and then the extrinsic things, meaning those coming from user interactions. We also have issues related to things that are being developed, as well as how they evolve after development, which I'll get to on a later slide. This little figure, it's probably a little bit small for people to read. Essentially, it was just looking at safety reports from FDA-approved AI tools, and the big takeaway was that in blue, you had these kind of extrinsic factors of user input and use, and that only made about 7% of the reported safety incidents for the tools, and about all the rest were essentially of things going on inside the device. Most of the time, the errors were actually in device input, but about 11% of the time, there were actually errors due to the device processing the AI kind of algorithms themselves. And right now, in terms of responsibility and accountability, physicians hold a unique position of authority. And this authority is really recognized by patients, recognized by the state. And this is really because we've been thought of as a trustworthy profession, makes recommendations based on evidence and our experience that can be explained, interrogated, and audited. And there are really also limitations placed on that authority. And at present, AI seems to be able to communicate expert knowledge, but it's neither really thought of as authoritative or responsible. And so we as experts are kind of left in the middle of accessing something with a different type of knowledge to us, meaning that we have some obligation to make use of that for the benefit of patients, but also have to expect responsibility for its use, for its misuse, and errors that might occur. And in practice, the easiest way to think about it is this. If I use an AI tool, I'm still the doctor, and so I'm still accountable. There was a law out of California that was passed in September that was called something, and I would probably misquoting slightly here, but it's like something about doctors make choices, and it's essentially that the physicians are still legally the ones who are making the choice and legally responsible for that choice, even if they use AI tools. Interestingly, when we asked about 200 oncologists a similar question in a survey, about 90% say that the AI developer should be responsible for medical legal issues stemming from problems in their AI model, while slightly less than half thought the physicians or the hospital should be held responsible. So, food for thought. Relatedly, much of our professionalism is really based on being that gatekeeper of knowledge and experience and interpreter of the data. On the scale of health literacy, we tend to place ourselves far above or different a layperson, sometimes appropriately, sometimes not. There's a lot to say on the ethics of power differentials in medicine, but that's not for now. If we, even think about the interpretation, the data acquisition, the explanation being shifted to AI, we're also kind of moving ourselves away from that ideal of being the gatekeeper of everything health-related and moving us slightly more towards the patient. This may, not completely undermine our professionalism. This at least has to reframe our self-conception as a professional and kind of think about what are our roles in this new place. And in the clinic room, if you have, a patient who's not particularly trusting, sitting there with an AI app, recording your conversation, pointing out where the AI disagrees with you, there is definitely a shift of power, the potential for widening mistrust, depending on how you react. And while this might seem far-fetched, there is an AI company in India that's working with one of their hospitals, and kind of patients are able to request a report about their treatment and take them to their doctor about whether or not this AI disagrees with what they said. So it's coming, and we need to be prepared. Now, Deb had also mentioned that we have myriad biases as people, and it's including how we interpret evidence, how we think about others. And there's been a lot of concern, very rightly, about how AI can be biased based on the data we put into it, the fact that we hold biases and that we're the ones that are training it, how we program it to make predictions, and how it might change over time. And so this kind of training biases I put on the left in terms of things that are there for kind of all types of different research. But usually when we have static drugs or devices, this is where the biases come in, and then they kind of stop because we kind of have a certain amount of bias, and then the study comes out and we can either apply it to the patient with those biases or without. With AI, the idea is that over time it's going to continue to learn, and so there are a bunch of additional biases that come in terms of its adaptation to different settings. And I think the interesting thing here is the thing that I have highlighted in the red box, and that is really how do we think about our interacting biases with AI? Can we use it to check our own biases, to check the AIs? This was a study that came out last month. I apologize for the pixelated nature of the figure, but it's actually due to the paper and not to me. The study was essentially asking different questions about diagnostic reasoning and comparing the ability of ChatGPT in the red by itself to physicians by themselves in blue to physicians with ChatGPT in green, and showing essentially that the AI by itself outperformed physicians with AI by about 15% in the study. And I bring this up to note that this was mainly because physicians were having anchoring biases on their diagnoses, which ChatGPT didn't have. And this really speaks to how we may need to move into more training and how do we use these things to check our own biases, and that this continual call for human in the loop might actually not be the right thing. Since this is a little less relevant to the day-to-day of clinic, I will keep this brief by saying that we already have a number of ways that we interact with large for-profit healthcare companies whose goals are things other than patient health. And so, for having this kind of new class of oligopolies and kind of the foundational LLMs, we need to really think about how they're interacting with the other companies as well as how they're interacting with us and our patients. I'm not going to go too far down this, but just to say that, we need to consider the goals of those who make the AI and kind of consider who's in the room when they're made and how the decisions happen. Now, while we all kind of aspire to always treat the patient and not the disease, we're bound by the pressures of time, being human and having many other responsibilities outside of clinic. The fact that I woke up at 2 a.m. to fly a couple times to get here means that if I have to go through 100 patient messages tonight, I may be a little bit more concise or even snippy than usual. But AI doesn't have that problem. It is always empathetic. And when we have this, we can see a different study from last year that was essentially looking at how the quality and the empathy of different patient responses, or physician responses or chatbot responses to a patient portal messages were. You can see quite clearly that the chatbot was ranked by patients as being both of higher quality response and more empathetic. Now, this provides evidence for both the promise of using chatbots to help with the volume of patient queries and concerns really about the acceptability of such practices in the broader sense. Is empathy without effort as meaningful? In the short term, I'm sure patients will appreciate this. I will say that a different study actually exposed the kind of result of who was answering this to the patients, and then they kind of reverted back to thinking that the messages were not nearly as empathetic or of high quality as they thought here. But it's really saying that if we continue to kind of use a bot like this, is the meaning of the message when we're actually empathetic with patients versus needing to kind of move on to the next thing. If we're perfect each time, does it count as much for patients, or is it more the experience of the person who's needing to empathize that we really recognize? More generally, I think we can think about this as ways that AI might help or hurt human relations in terms of compassion and dignity, and in terms of kind of decreasing things like social isolation for our patients, down to being able to help us role model, and from the negative side, actually furthering social isolation, as I said, kind of effortless empathy. I won't touch on this for too long, but just to say that we've heard in other sessions, as well as at the beginning, that AI can hallucinate, kind of like how we can either lie or incorrectly remember things. I think we just need to think about this as, in this conversation here that you're probably reading while I'm talking, is essentially saying that there are some completely fabricated, out of whole cloth references here that the AI is very confidently putting into the chat on a very sensitive subject. And the fact that it can do that makes us really need to kind of check it, have provisions for responsible use. Now, for many stakeholders have cited the need for explainable AI. In that same survey that we performed, 85% of oncologists thought that AI should be explainable by them in the clinic to really accept their recommendations. We currently, though, accept unexplainability from our doctors, and that does need to be acknowledged. We think of this idea of explainability or explicability as a tenet of clinical medicine, and that we're kind of evidence-based in our decision-making, but there's really so many nuanced decisions that the evidence-based doesn't apply to, and also that includes kind of a mixture of intuition, experience, and gestalt. And when it comes to generative AI, this kind of same problem can occur with a few additions. The first is that, as I said before, we as physicians accept that we're doing this as licensed professionals with responsibility for these decisions, and when the decisions are particularly thorny, we can also go to others and ask for their opinion and get consensus. There are some newer agent-based AI models that can also kind of ask their AI friends, but nonetheless, they are still not licensed professionals, especially in California at this point. And there's also an argument that a lot of the nuance of clinical decision-making may also just fundamentally exist outside of the medical record, and unless we reach the point where we're okay kind of monitoring and surveilling multimodally through microphones and videos and everything else in clinic, some things might escape the all-seeing eye of the LLM. And while we do have this persistent issue of hallucinations, which I mentioned on the last slide, to make us cynical of recommendations, we do need to think about this really crux of complex decision-making. If the AI is consistently superior at decision-making than us, but is able to explain it and is wrong, is that still more acceptable? Is that not acceptable to us, but as a patient, I might still want that? I think that's kind of the fundamental question. Now, related to the idea of inexplicability is that of patient consent. AI can provide us tools that might potentially improve the process of consent, that is, help patients make more informed choices. Excuse me, the cough's coming back. Apologies. My voice just about went right now. But if we, excuse me, this is going to be tough. So we have the idea that for consent, we need to have patients have consent to use AI in decision-making. The idea that patients have to use consent for the data for their consent of use for their tools, consent for use of their data in AI tools, consent for studies that might use their AI, use their in clinical care. Excuse me. And consent to a study that doesn't actually assess AI, but that uses AI in it. Oh, thank you very much. I really appreciate that. And I think the speaker from the last session actually brought up a very interesting point, which is where they'd used essentially an AI tool to screen patients for clinical trial eligibility and had whittled down hundreds of patients to a few that were promising in terms of the genetic marker. that they could then actually screen and test. But the interesting thing about that was it improved efficiency, improved enrollment on their clinical trial. They didn't speak to how it actually might have excluded some patients from being screened in the first place. And the idea that using these AI tools without consent to patients and having their data kind of processed through these things would allow some patients to potentially have less availability of clinical trials to them because they weren't kind of pre-screened eligible is a very interesting one and something that I think I would love to hear our patient advocates on the panel speak to. Now, due to my voice, I think we can just pass on this and just say that it is interesting to hear that environmentally mediated harms actually happen. The amount of greenhouse gases that the US healthcare system produces leads to the same amount of disability-adjusted life lost as colon cancer each year. And so with AI models, and AI companies buying up nuclear power plants to support their activities, we really need to think about the downstream health harms of integrating AI throughout our practices. So I will stop there, and thank you for bearing with me. I apologize about the voice.
One other thing just to remind you guys of as our next speaker is coming up that you can submit questions through the app, which will appear digitally, or when we've completed all the speakers. There are 4 microphones there where you can come up with questions.
All right. Hi, everybody. Pleased to be here today. My name is Ian Maurer. I'm going to talk about generative AI. So really kind of deep diving into, here we go. I work for a company called Genomoncology. Deep diving into large language models, try to give you an intuition on how these things work, why they work, so that you can best take advantage of them. My favorite analogy of large language models is that they're word calculators. So just like a regular calculator can help you manipulate digits, a word calculator can help you manipulate words. This cartoon shows I could take a sentence, turn it into a paragraph, or I could take a paragraph and turn it into a sentence. That's effectively what these things do, and they can be used for a variety of different tasks. So why is it happening now? Like, what happened in December 2022 that gave us the ChatGPT moment? And really, it's just an impact of these 4 things. Scaled compute, NVIDIA GPUs and other GPUs, scaled data. We've been collecting information on the internet with our phones in the cloud. A paper called the Transformer Architecture that was announced in 2017. And then really the key unlock in my mind is this idea of self-supervised learning. If you're familiar with machine learning and other artificial intelligence strategies, labeling data, curating the data, and training your models is a very expensive and time-consuming thing. This self-supervised learning capability really unlocked it. And these are 2 different ways that self-supervised learning work. The first is what's called encoding, which basically takes text from the internet and does what's called masking, hiding one of the words. And then to train the model guesses what word was masked. And then doing that over and over and over again, the model gets trained, gets smarter, and then it does a better job of guessing that word. Another algorithm is what's called GPT, Generative Pre-trained Models. And their job is to guess the next word. And really, that's how these things work. They've been trained on all of the text on the internet multiple times over, and this is their capability, right? Given us 3 words, the sky is blank, the large language model can then predict the next word based on percentages, a probability, right? So the sky is blue. So why is that interesting? Well, really, that core capability can then be unlocked for using and allowed to do a bunch of other tasks, right? Whether it's coding tasks, which is really where these things have taken off the last couple of years, but reasoning and what's called in-context learning, which allows you to basically tackle any task with the right prompting and other usage, which I'll talk more about. So first, though, a warning to go along with our last presentation. Large language models are fundamentally unreliable. They hallucinate facts. So if you think about the fact that they're basically predicting the next word, they'll predict anything. as long as they think that that's the next best word to choose. And I'll talk more about that. They're a black box. We don't know why they work. The people that have invented these things don't know why they work. They're using toy versions of them, smaller versions of them, the old generation of them, to interrogate them and try to explain how they work. But it's still just like the human brain, where we kind of have ideas of where regions of things happen within the human brain. It's the same kind of techniques that they're doing on these large language models. They've been trained on the internet. The internet has bias on it. They've been encoded with that bias. Study after study has shown it. They're out of date. It costs tens of millions, hundreds of millions, and soon billions of dollars to train these models. And once you've trained them, you can't update them. It's not like you can go add another file to it after you're done. It's fundamentally not how the technology works, which is why they can get out of date. And so they'll say things like, oh, as of my last training cutoff date of September 23, the answer I think is this, but it could be completely wrong by that time. And then they're also incomplete, and they're not really a search engine. It's not Google. You're not asking a question and it's like looking up in a database and giving you an answer. You're asking a question, it's predicting the next token, next word, to basically come up with an answer that sounds right. And so there's lots of funny examples of this in the popular press, right? There was a lawyer that almost got disbarred for submitting his ChatGPT homework, and there were basically hallucinated cases, right? These were cases that don't exist, and ChatGPT just made them up. And then there was a chatbot where someone got the local Chevy dealership to sell them a Tahoe for $1, right? So these things happen. The models are getting better, they're getting more reliable, but recognize that they do have these weaknesses. And I really do like this article. These things are not competent. They have performance, they have capabilities, they have skills that are useful. But what they're doing is they're generating what a good answer sounds like. They are not generating the answer. And so how do we make these things more reliable, right? So first is making the models larger. Through larger models with more data, more compute, the models get better. There's fine-tuning, which I'll talk more about specifically how that works and maybe how that could work for your institution. And then there's these different techniques which are called in-context learning, which I'm the most excited about just because of how powerful they are, how flexible they are, and how quick it is to get started. So first, with the larger models, these things are just continuously getting better. We have this race. There's OpenAI, Anthropic, which has a model called Claude, which is my personal favorite model to use. And then Google also has their Gemini platform. And Gemini actually just came out with a new model, Gemini 2, just 2 days ago that beats Claude, Sonnet. So these things just keep getting bigger, keep getting better, and keep getting more accurate over time. And so that accuracy, that reliability comes from having a quote-unquote smarter model. Another technique that people do is what's called fine-tuning. So fine-tuning is to take a base model and then apply your custom proprietary knowledge or other information that you have, and then fine-tuning that model. This is really useful when you have an open source model that can be started from. So there are open source, open weight models from Meta, the Facebook company that has, those models are called llama models, but there's other companies that have produced these open source models. They're smaller, they're faster, they're easier to run, you can control them. One of the big benefits of that is you can actually download the models and run them on your own hardware. One of the challenges we're going to have over the next few years is if you do not control the model, the big API companies, the model companies, Google and OpenAI, they can change the model and then get rid of the old one that was working for you. And you're not really in control anymore. So this is a very usable way of kind of taking control of the models and then applying them to your use cases. But there are some negatives to it. There's the next series of tools are called in-context learning. So context is really the window of text that the large language model is thinking about, right? So the large language model has a block of text that it's in its memory, its working memory. If you think about when you're reading a book or a paper and you have a working memory of what you're reading, that's what the large language model has as well. They call that its context. And so whatever text is in that context, it can be used to drive the large language model to do its work. The different flavors of in-context learning that I'm going to talk about are prompt engineering, retrieval augmented generation, and tool usage. And the benefits of this is that it's faster and easier to get started, right? You basically can have your development team working with these large language model providers with their APIs, their programmable interfaces. There's no expensive data labeling, no expensive training. You're just building your applications. The great thing about that is as these models get smarter and faster, you can just swap them out. So if you were building something that worked with OpenAI, then Sonic comes out from Claude, you can swap to that, and then Google Gemini 2 comes out, you can swap to that. This is great from a software development perspective because we're just getting smarter models cheaper every 3 months, really. It's kind of like how the phones and before that, the computers were just getting faster and cheaper every couple of years. Training's expensive. Not only is it expensive computationally, it's expensive from a resource, like human resource perspective. The people that actually know how to do this stuff, they're expensive. Having that expertise in-house can be costly. Integrating with a cloud provider that has a model is a lot cheaper to do. And then the new models do get up to date with new knowledge and new information, as they get released. And then the other thing to understand about the fine-tuning that I talked about before, one warning, if you fine-tune on patient data, right, obviously you got to work through the regulations around that, but they can leak patient data. And so if you're training on them and, Mrs. Smith's record trained in the model, and then later on you ask the model about Mrs. Smith, it might start giving you personal information. So you really need to understand those risks when working with your development team. So what's prompt engineering? I'm sure everybody heard that term floating around on LinkedIn a couple of years ago. Prompt engineering is the idea of how do you actually work with these chatbots? Well, the great thing is working with a chatbot is kind of like working with an intern. So, step one, thing one to remember, they're word calculators. Thing two is their intern. And the intern is great because that they basically have access to all the world's knowledge. So they have access to Google or whatever. They're very eager. They'll do whatever you ask them to do. And you point them in a direction and they'll just start running, even if it's the wrong direction. So the best way to work with your intern, your new AI intern, is to follow these 5 steps. Right? Be clear and specific. Provide context and examples. Break down complex tasks. Don't make them do too many things all at once. Give them one task at a time. Specify the desired format and style. How do you want the response to be? And then iterate and refine your prompts. One thing you can clearly do is if you're having trouble with the chatbot and it's like getting confused, start over. Start the chat over and basically start from the beginning with the clear directions. So a few examples of what's called prompting or prompting strategies. The first one is giving it examples. Right? If you tell it what good looks like, it'll have a better job of actually doing that. Right? And they use the terminology shot or exemplars in the literature. So 0 shot means I'm not going to give you any examples, I'm just going to ask you to do a task. In this case, translate something to French. 1 shot means I'm going to make a request, please translate things to French, and here's an example of what good looks like, and then you ask for it. And then few shot just means what it says, just give a few examples. I have applications and tasks that I'm doing that I give it hundreds of examples because the context windows are so large that I can do that pretty affordably, and it's actually cheaper and actually more effective than fine-tuning a model. Another technique is called chain of thought. And really what this is simulated reasoning. So you ask the model to not only give it an answer, but to explain its reasoning, explain how it thought through the process. And the reason why this works is because these things actually, quote unquote, sorry for anthropomorphizing, but they think by writing words. It's just how they work. So on the left, you'll see a standard prompt where you say, okay, it's some simple word problem, and it's actually a one-shot example, right? It's a question, the answer, but there's no explanation, and then another question, and then the model gives its answer. In this case, the model doesn't have a chance to kind of explain its thought process, and it gets the answer wrong. On the right-hand side, you can see an example of chain of thought prompting where you give it the word problem, but in the example answer, you show that the model should explain itself. It should really think through the process. And then you give it another question, and then when it gives the answer the second time, it thinks through the process and it has a much better chance of getting it right. And so this is called chain of thought. There are papers about it. And really, this is kind of the key insight that goes into this new generation of reasoning models that you might have heard of. So OpenAI has a new model called O1, and it's a reasoning model. And what they've done is they've fine-tuned their standard GPT model. We don't know exactly how it works because they're kind of keeping it hidden. But basically, the idea is they've trained it to do this millions of times, right? They've given it math problems and other things where they know how to actually reason out the answer. And now the model basically, when you ask it a question, it will do this whole chain of thought reasoning behind the scenes, and then it will finally give you your answer. There's a great, if you're interested in learning more, there's a great website called the promptingguide.ai that you can find all of this, find more examples of this, all pointing to the different papers and examples on how to actually work with it. Retrieval augmented generation is another technique that's very powerful. This is the idea of combining a chatbot with a database or with a search engine, where you basically ask a question, the question can then be used to retrieve the relevant content from the database, put that in prompt, put that in the context, and then the chatbot can do a much better job of answering the question. This is great for domains like biomedical research, right, where the information is very dense. You want to bring that information in and then have the chatbot has a much better chance of not getting confused and not hallucinating, but it still can, just be aware. Consensus AI, there's a lot of these tools that are out there that let you do research and let you understand PDFs. Consensus AI is a nice tool, which basically does what I described. It'll search, it has a database of all the PDFs from PubMed and from other resources. It can then bring back the relevant content and then reason over it. Perplexity is a very good platform for general RAG application. And then tool usage is really the last example of in-context learning. And this is the idea of, a chatbot is not a good calculator. If you ask it a simple math problem, it will give you the answer because it's had in its history, 1 + 1 = 2. That's on the internet everywhere. But if you give it some long division or some other more complicated math problem, it'll probably get it wrong because it's not a calculator. But if you give it a calculator and you tell it how to use the calculator and then you give it that math problem, it can happily just use that calculator. Same thing with the weather. Obviously, the large language model doesn't know the weather, but if you teach it how to ask the Weather Channel how to get the weather somewhere or how to find a hotel geolocation, it can do that as well. So these are examples of tool calls where a user can ask a question and then it can call a tool to bring back the result. And the way I use this stuff in my day-to-day is what's called a knowledge graph. So Genomoncology has a knowledge graph of all the FDA approvals and NCCN guidelines and clinical trials and the different genes and their variants. So our knowledge graph has structured knowledge that's explicable. I can tell you the answer. I can tell you why I give you an answer. I can point to you the page in the NCCN guideline or the sentence in the clinical trial document on why we're making a recommendation to include or exclude a patient. And then there's another great paper here that has how we could use this information across a variety of different sources, right? Whether it's evidence-based medicine or literature searching. And so in my world, the idea of clinical trial matching is a two-sided problem. OCR, optical character recognition, if you're familiar with that term, it has been a hard problem for 40 years, right? It's basically solved now. These large language models have a vision capability to them, quote unquote, a vision, which means that they can read text and, to great accuracy and extract it out in a structured format. And that's really taken off this year for me. And then in my world on that right-hand side is really our knowledge graph for clinical trial matching. And so we're using these large language models to first extract and clean and normalize patient records and other medical information into a structured format so that our clients can actually take advantage of it. And then on the right-hand side is our knowledge base that we deploy to our clients. And then this allows us to kind of bring these two worlds together. And so in our world, we've got thousands of clinical trials, thousands of FDA and NCCN guidelines. And we are already doing good old-fashioned AI on trial matching and therapy matching. Good old-fashioned AI is the idea of white box reasoning using knowledge graphs. And so we can take multi-omic data, clinical data, prior intervention, staging, NGS data, IHC data. We can match that up to our clinical trial database where we've curated by hand, by human experts at the arm level. And then we have on-premise and private protocols, so our clients, sometimes they have their trials that are up on clinicaltrials.gov and they're not up on clinicaltrials.gov, and we have to curate them locally for them. Integrated with their CTMS or EHR. And then we get these data feeds from these NGS providers like Tempus and Foundation Medicine. And then we extract and normalize that using optical character recognition and natural language processing. And then we can find patients for trials, or we can find trials for patients. And that enables enrollment and feasibility and clinical decision support. And then we can also recommend the next test, right? Like maybe the patient doesn't have full coverage of all the genes that are necessary to get on a clinical trial, so we can recommend those tests. And then we can also expand querying in our system. So, our system has an understanding of the oncology, disease ontologies and gene ontologies and other things like that. And then that system, that white box, good old-fashioned AI knowledge graph system allows for algorithmic matching, right? And unfortunately, if you're you're a treating oncologist, my system can give you 10 or 100 trial matches, right? Based on what the patient and their disease and stage and the biomarkers. And the problem facing an oncologist is that 100 trial matches is about as good as 0 or about as a million, because you don't have the time to dig through all that information. And so the next thing, so we've been using large language models to extract patient, unstructured patient data to help our cancer centers make use of that unstructured data. But wouldn't it be great also to use these large language models to help with the decision support, right? How do we go through all of those trial matching and aid and augment and amplify the oncologist's time so that they can dig through those algorithmic matching way faster? Get it from 3 hours or 5 hours of work down to 5 minutes of work, where they know that they're making those best possible recommendations. Get that best single match. And then could we then explain to the patient in patient-friendly terms, what's the trade-offs? What are you giving up to be on this trial? Or, what bad things might happen for being on this trial, but what are the positives that could emerge from this trial? Like explaining to those in full terms are another great opportunity for these large language models. But once again, we need to account for the hallucinations and the bias and the other challenges. And so, that's where, I'm spending a lot of my time right now is how do I help oncologists use the tools we've already built, but do that in a way that impacts, can also not just decide, oh, you've got this biomarker and this disease type and this stage, you match. How do we also think through things like quality of life, adverse effects, the trial design, the intervention type, and maybe there's modifiable criteria. What are some things that the doctor can do to help the patient qualify for the trial? And then just in general, reduce barriers and increase access to everyone. And so this is called the Genomoncology GPT. It takes advantage of the different multimodality, being able to take pictures, be able to talk to your phone. I think in the next couple of years, Google and Apple will just have great assistants that just work on everybody's phone. And they'll be able to work with any tool, right? And those tools will be out there to book a flight or to tell you the weather, but also hopefully to do things like do some basic research to augment and amplify our knowledge. And so this is, the way I do it is through this thing we call our patient avatar. So the doctor can just basically chat with the chatbot and describe the patient and whatever information that they know about the patient. And then that is used to power this little experience. So just a quick demo for you. I'm taking a picture of a dummy foundation report, and it's sending up the data to our API. The chatbot is actually doing the parsing for me. It's reading off the biomarkers, it's reading off the disease type and other information off the report, sending it to the back end, and it's generating the clinical trial matches. And then notice that it gave me way too many trials, so I said, oh, actually I live in Lakewood, Ohio, go ahead and filter it by that. And so then it's gone ahead and applied another level of filtering that lets me just get the trials closest to me. But there's so many other opportunities for allowing the oncologist to kind of have a dialogue, right? A natural language dialogue with their assistant, and then the assistant has access to all the tools within the cancer center, where they're bringing in data from the EHR, the clinical data warehouses, the clinical trial management systems, and then bringing that together to bear for that physician to make sure that they are fully augmented, fully amplified, and that they're maximizing their time and hopefully reducing burnout. So that's my story. Please connect with me. I'm up on LinkedIn posting things, and feel free to send me an email, and I'll be here this afternoon if you want to ask any questions. Thank you very much.
Good afternoon. It is my privilege to follow those outstanding presentations and to invite you to think about how novel digital tools can be integrated with oncology clinical practice. I'll wait just a moment for my slides to come up. Thank you. So I have no financial relationships to disclose. And to start, I'd like to invite you to step back in time. Think about the doctor's kit of your childhood. This one looks a lot like the one that I had. And here's an update version. This is the one that my kids have now, and you can see how a doctor's tools have evolved over 40 years. The oncologists in the room can appreciate the addition of the emesis basin, as well as the addition of glasses. You have to have those to be taken seriously in the clinic, especially as a young doctor. And perhaps the most important innovation is the addition of the smartphone. But I'm a bit old-fashioned, perhaps, in my medical practice. I still wear a white coat. I keep a stethoscope around my neck, and I actually use it. I have a pen light in my left coat pocket, and I print my list or my rounding sheet before I go to see my patients, and I jot notes with a pen to keep track of the patient's history and the plan of care. And I can tell you it is a very bad day if I lose those notes. They are truly an essential tool. But in reality, the tools that we use in medicine in 2024 are very different from the past, and for many are different from the tools of our medical training. And as much as we hate to admit it, our computer may be our most essential tool these days, something made all too clear if we have an unexpected system downtime, which can bring much of clinical care to a screeching halt. And so where will we see the next innovation? What will a doctor's kit look like in 2034, 2044? Will any of these prior tools be missing, replaced by new technology? So this is what Deep AI image generator produces when you type in Fisher-Price doctor's kit with modern tools. I'm not quite sure what each of these tools is meant to represent. I'm relieved to actually not see a keyboard. Perhaps the device there on the left is listening to everything we say and capturing it. And I'm not quite sure what we're supposed to do with each of those tools down front, which part of the body they are meant to evaluate. But like this image, we are all reimagining what a medical provider's tools look like now, and importantly, what they will look like in the future. And so today, I'd like to expand upon the ideas that were shared by my colleagues and walk you through a day in the life of a breast oncologist and where we can leverage digital tools, including AI, to better meet the needs of patients and clinicians alike. And possibly the first most obvious and essential innovation has been the advent of electronic health record systems, which are nearly universal in the United States and in much of the world. And this movement was accelerated by the 2001 publication of Crossing the Quality Chasm, which noted that healthcare should be supported by systems that are designed to produce care that is safe, effective, patient-centered, timely, efficient, and equitable. But the report noted that instead of this ideal, healthcare costs too much, is inefficient, and of poor quality. And they posited that health information technology could be one way to cross the quality chasm. And so electronic health records are really part of the everyday fabric of clinical care. They afford access to prior medical records. They provide at least semi-comprehensive lists of medication, medical problems, test results. And we have to admit, they do provide some benefits, some efficiencies gained, some improved ability to communicate, improved clarity of patient histories, and do enable us to share some patient information. But there are some challenges too. We can actually be overwhelmed with the amount of data that's present in the electronic health record, much of which is in unstructured data forms. There's a documentation burden that is increasingly problematic for clinical providers, and our systems don't talk to each other very well. So a patient who receives care in multiple locations, there may be some compatibility issues with medical record sharing. There's also this growing expectation that providers are accessible at all times by multiple means with the use of chat functions and patient portals. But I think it's safe to say electronic health records are here to stay. And so in my clinical work, the care of patients starts with prepping for clinic, particularly if I'm seeing a new patient, which involves synthesizing large amounts of data, clicking through the medical record. I just lost my slides. I'm gonna let go of the mouse and see if folks in the back can get my slides back. But there's a need to click through large amounts of information and synthesize key data elements. Things like imaging, pathology reports, comorbid medical conditions, and prior history, including prior therapies, are all essential for us to prepare for the patient's visit. And so perhaps this is a place where artificial intelligence could assist clinical teams. Thank you so much. Thank you. And so maybe AI can do some of this work for us. And this has been studied by Dr. Lee and colleagues from Seoul, Korea, who presented their work at the 2024 ASCO annual meeting. And what they did, they conducted a study to develop and validate an AI system to summarize oncology clinical histories. And they further explored the use of AI to develop treatment plans, which I will not discuss today. They examined 50 breast cancer cases using all available medical records up until the point of the initial treatment decision. And all cases were processed according to 3 different approaches: fully AI, AI-assisted, and human only. The full AI and AI-assisted approaches involved use of large language models to process existing medical records and generate AI summaries. The human components of this workflow were conducted by 2 oncology physician assistants. And then all summaries were reviewed by 8 board-certified oncologists who blindly evaluated the summaries for faithfulness, completeness, and succinctness using a 3-point scale, and then they ranked their preferred summaries. And so you can see here that the output of each of these workflows generated what appears to be pretty similar summaries across cases, pretty similar in terms of their formatting. So what did they actually find? So in their rankings in this far left figure, they found that AI-assisted is preferred by the board-certified oncologist over full AI and human-only approaches. And interestingly, full AI was preferred over human-only. And as you would imagine, in the middle graph, you can see that the AI improved the time that it took to summarize key data. And then on the far right, where higher is actually better here, AI-assisted had the highest faithfulness, completeness, and succinctness of all approaches, and full AI was better than human-only for completeness and succinctness, and almost as good for faithfulness. And so we can see from this work an example of how AI can be used to extract key clinical information for patients with breast cancer and can translate to improvements in quality and efficiency. This could actually make our lives easier as clinicians. But there are some challenges with implementation. So first, large language models have to be trained on key data elements, and which elements are key is going to vary across medical specialties and even within oncology across tumor types. And so can we really implement separate models within an electronic medical record system for every disease state? Second, EHR systems are not sufficiently nimble to incorporate new tools. We often lack the human power and computing power to easily embed new tools in the EHR. Tools that are external to the EHR are not sufficiently timely for clinical care. To send data out for AI processing and then receive summaries back needs to be able to happen in real time for us to do our clinical work. And so these implementation challenges may limit the uptake of AI-generated summaries in the near future, as much as I would like for these tools to be available right now. Another clinical task in which we can leverage digital tools is in estimating risks of clinical outcomes. And we already do this quite regularly. We use existing risk stratification tools, most of which are developed using logistic regression or Cox proportional hazard modeling, not artificial intelligence. Things like Predict Plus or the FRAX tool or RSClin, which the breast oncologists in the room are undoubtedly familiar with, and maybe some lesser known tools like PROACT, which can predict acute care events among cancer patients receiving active treatment. And then a newer tool that my group has developed called the MBC prognostic tool, which helps predict the risk of near-term death in patients with metastatic breast cancer. And so I'll just give you an example. This is from Predict, a screenshot. This is a publicly available online tool. And you need to input several bits of information about your patient and their tumor, which often involves kind of clicking back and forth between the patient's record and the web to glean the information that you need. All of the information that you need is available in the EHR in a structured field, but we don't currently have a way to push the data from the patient's chart into the tool. So right now it has to happen manually. And in large part, because of the widespread use of electronic health records, we are now able to leverage large data sets to develop risk stratification tools. And there's tremendous potential for new tools to be developed and implemented that can improve clinical outcomes. But several studies have shown, as I think was alluded to earlier, that tools built on regression models are more easily understood by clinicians compared to machine learning or AI. And that regression-based tools have increased acceptability to clinicians. We tend to trust the tool more if we can understand how it was derived. But there can also be challenges of decreased adoption. We often think that we can outsmart the tool if we understand it. And so there are also important and rising concerns about the risk of bias in model development and use. Issues with modeling data or sampling can lead to biased predictions that support decisions that are differentially harmful or beneficial across groups. This then raises concerns about fairness when these models are used to guide treatment decision-making. And again, we encounter challenges of inflexibility of the EHRs when trying to implement these calculators. This is true even when the data elements within the tool exist within a structured field, but especially true when the risk stratification tools require any unstructured data elements. The lack of human power and computing power is an ongoing challenge that limits incorporation of these tools. And these implementation challenges contribute to this idea of research waste, when tools are developed, often using public funds, but never really incorporated into clinical practice. They sit on a shelf or in a journal publication, never be used in patient care. And so tools that are external to the EHR, like our web-based calculators, they require extra clicks, more time for the clinicians. And when you're trying to influence clinician behavior, such as raise awareness among clinicians about which of patients might be at high risk for ending up in the emergency room, a major problem with external tools is that they require the clinician to seek the tool, when instead you'd prefer to systematically evaluate risk amongst a patient population and present clinicians with data that they didn't really even know they needed. And I think we're on the verge of being able to overcome some of these challenges by leveraging new technologies. EHR systems must figure out how to incorporate new tools, including AI, within their platforms, and then use AI to improve the quality and completeness of the EHR-derived data, including processing unstructured data from free text notes and converting it to structured forms. We should be able to pull data from the EHR into powerful risk prediction tools in a way that minimizes user data entry and also further allows us to build new tools derived from higher quality data. And so in order to do this, health systems will need to invest in personnel and resources to incorporate and maintain risk calculators. This work has to cross over from the research space into the care delivery infrastructure. So going back to the exam room, I think clinicians must be actively involved in implementation of risk stratification tools in the EHR to make sure the right tools are available and make sure they are made available in a way that's compatible with the needs of clinicians and enables us to better serve our patients. One of the biggest challenges facing oncologists is the need to make treatment decisions in a landscape that is increasingly complex. Despite robust guidelines for oncologic care, there are so many factors to consider when devising a treatment plan for a specific patient. And so oncology clinical pathways, which are guideline-based treatment menus, are one way to try to aid treatment selection with technology. Their potential benefits include increasing consistency of evidence-based care, managing drug use and reducing drug costs, lessening the administrative burden associated with payer appeals, these so-called gold card programs for practices using pathways, which can minimize the need for prior authorizations and appeals. They can also be used to capture stage and molecular data and promote accrual to clinical trials by reminding clinicians which trials are open at their site. But as anyone in this room who uses pathways can attest, there are several challenges. It's actually pretty easy to go down the wrong path, and as a result, this goal of guideline concordant care is not always achieved. And conversely, sometimes it's hard to go down the right path. It takes extra clicks and clinician time to select the regimen that perhaps you were already certain you wanted to give your patient. Also, the data between pathway systems and the EHR is not always bidirectional. So we have to input staging and biomarkers in both places, and it doesn't always feed back. And so that's both a problem for clinician workflows, but also for improving the completeness of clinical data. And while we know that pathways can improve some health system outcomes, including efficiencies and costs, it's not always clear whether all this extra clicking actually translates to improved patient outcomes. And so overcoming these challenges does require physician governance and pathways. The menu items within pathways should be driven by evidence and clinical care guidelines, not simply the lowest costs. We also have to be able to pull data directly from the EHR to minimize user data entry and error, and then push data back to the EHR to summarize treatment plans and improve data completeness. Both will translate to fewer clicks and efficiency gains. We also need health system investment in personnel and resources to incorporate, maintain, and evaluate oncology clinical pathways. These systems cannot be deployed without some education and clinical support for clinicians and substantial IT efforts to link pathways to treatment plan orders. So I think implementation science and project management strategies can be leveraged to try to improve the adoption of pathways in our clinical settings. We need to evaluate how well pathways are adopted and where are their barriers to use. And we can then target those barriers with strategies to try to increase their use. Importantly, we need to study whether when they are used, these pathways can enhance workflows and actually improve patient outcomes. And as we care for our patients, there are also numerous opportunities to leverage digital tools to better understand and respond to patient concerns. Digital symptom monitoring systems, including patient-reported outcomes or ePros, have been shown to improve symptom control, quality of life, length of time on treatment, hospitalization rates, and overall survival in patients receiving cancer treatment. But real-world implementation of PROs has been challenging, and that could be a whole talk in and of itself. This was beautifully presented and discussed yesterday by Drs. Karsten and Rock in the general session. So I would commend you to watch that presentation if you've not already done so. Responding to patient concerns can also be challenging and increasingly time-consuming for clinical teams with the rising use of patient portals and the eventual rise of PROs. And so how can we leverage AI to respond to the increased volume of patient concerns and symptom alerts? In this study, the investigators examined whether generative AI drafted replies would correlate with decreased physician time on reading and replying to patient messages. And this study included 122 primary care physicians, and AI-generated replies were compared to physician-generated replies. And they found that AI-generated replies correlated with increased message read time, no change in reply time, and significantly longer replies. And while that does not sound exactly like a successful implementation of a digital tool, perhaps there is still an opportunity here. If technology improves such that models can be trained on a particular clinician's prior responses, then read time and need for editing may eventually improve. And maybe the timeliness of our responses to patients could be improved if AI-only responses without clinician input could be used to answer simple or common patient questions, scenarios like fever in a patient on chemo, inquiries about the safety of vaccination, or common symptoms like nausea, mouth sores, or constipation. These could all be easy targets for an AI-generated first reply to patients. But would we ever really feel comfortable turning over the reins? Clinicians don't really like the idea of being unaware of patient concerns and unaware of the AI-generated responses. And if the clinician does not review the patient concern, we lose touch with how our patients are doing and possibly the other important aspects of their lives. And I'll give you an example. So if someone sends me a message saying, Dr. Ray, I'm leaving tomorrow for my trip to Spain and I'm worried about the amount of diarrhea I'm still having, the AI can advise the patient to up-titrate their antidiarrheals. The AI can even wish the patient a great trip. But if I don't inquire about the trip or the diarrhea the next time I see the patient in clinic, we've lost some connection there. Also, it may be a lower cognitive lift for physicians to reply to a message with their own original thoughts rather than read and revise an AI-generated message. So can the technology be trained not just on generic algorithms, but on a given provider's typical responses? For example, my navigator can tell you that I hate magic mouthwash. I don't prescribe it, and I would want an AI tool to know that about me too. I would also want it to know the preferred language, including the nice things that I typically say or the well wishes that I offer my patients. Interestingly, in the primary care study that I mentioned a moment ago, some of the providers found the AI-generated messages to be overly formal or actually too cheesy or overly empathetic. But others kind of appreciated the injection of pleasantries that they might otherwise be too busy to input in a message. So in some ways, the AI made the doctor look better than they would have on their own. So I think there's still need for considerable improvement in these technologies to make them more patient and clinician-centered. Next, there are other opportunities to integrate digital tools that I have not covered in depth today, but I'll briefly mention here. This was discussed in the last session, the use of AI to improve pathology and radiology interpretation, the use of AI in clinical note writing with the goal to remove the drudgery of that task, but not rob us of the opportunity to synthesize our thoughts, which is often an important component of writing notes. And then, as was discussed earlier, looking at clinical trial eligibility, integrating complex clinical data with complex inclusion and exclusion criterion. I think the area of perhaps the most exciting application of digital tools in oncology will come with learning health systems. This idea of leveraging science, informatics, incentives, and culture for innovation, improvement, and to embed best practices in care delivery. We need to capture new knowledge along the way that further informs evidence and then loops back to improve clinical care. High-quality data and the ability to analyze those data are key links in that chain. A major challenge with learning health systems is figuring out how to integrate multiple data sources, how to analyze those data in a timely manner, how to use it to evaluate quality metrics, and then feed those metrics back to providers and health systems for things like quality initiatives and value-based payment models. Novel technologies, including AI, can help address the complexity of data. We've already seen that AI can reasonably synthesize key data elements into usable formats and do it much faster than current human approaches. Because most data integration and analytics currently happen outside of health systems through data sharing and agreements with external big data companies, there are financial and logistical barriers to widespread use of learning health system approaches. But improved data integration quality and timeliness through AI may help aid the return of quality data back to practices. And so ultimately, we hope to leverage digital tools to give us more time and deeper knowledge in the hopes of increasing and not diminishing our human connections with our patients. To do this, providers and patients must be integrally involved in decision-making around the design and implementation of digital tools to make sure they truly enhance rather than detract from care. And while people have questioned for decades whether doctors will eventually be replaced by computers, this quote from Dr. Warner Slack really resonates with me. There is a deeply human component to our work, not just to heal, but also to comfort. And so I invite you to reflect on how we can adopt powerful new digital tools and still preserve a human component. Thank you.
Beautifully said. We are going to open this up for questions for the next 15 minutes now. And so I have some in the chat, and then if you have some and you want to go to the microphones, please feel welcome to do that. I'm going to give this one first to Ian. What efforts are underway to train AI to minimize hallucinations?
It's a fundamental problem with the way large language models work. That is just how they work. They are basically hallucinating this word. And so the main things that I described earlier were making the models bigger, because by actually making them bigger, they do become more reliable. There is this idea of reasoning models. So this is, technically it's called test time compute. And what that means is rather than just relying on the fact that you've trained it on the internet and I guess Elon Musk built a thing in Memphis in 6 months that is the biggest computing thing ever. Rather than just doing that, you give the models more time to think. And by giving them more time to think, they'll give a more reliable answer. But I really believe that fundamentally what we need is basically a three-legged stool. The three legs in my world model are large language models paired with something like a knowledge graph or some other kind of guardrail rules-based system that has codified knowledge that is agreed to, and then humans. Right? Those three things together are the best way to maximize the value of these large language model tools while minimizing the risk that's involved.
And then another question, and Andrew, maybe this one is good for you, relates to the issue of bias. How are we ensuring that use of AI in trial matching isn't perpetuating or worsening the abysmal rates of people of color in oncology trials? And I think this speaks to, like I said, the broader question of bias. What things can we do to better understand and mitigate bias?
It's a great question. So I agree. I mean, I think in the numerous things that he pointed to, it said that all of these models are trained on biased data sets. We know that biobanks, pretty much any real-world database that you get your hands on, all has overrepresentation of some groups and underrepresentation for others. And I think just like in the ways that we consciously think about checking our biases when we're talking to a patient or reviewing data or talking to our colleagues, I think that same process is essentially what needs to and in some ways is being built into some of these tools. And I can speak to, there's the Coalition for Healthcare AI, which is talking about kind of a federated review across the United States when AI tools are being implemented in different settings. And that gets to some of that idea of emergent bias where you have a tool and you have understood its biases when you're developing it, but with AI and its kind of continuous learning, it may lead to new biases that happen over time. And so you kind of need to have a continual monitoring system. And that's what the kind of federated Coalition for Healthcare AI is talking about, is kind of having that check not only at the beginning, like we would have with FDA-regulated drug and device pathways, where there's a lot of checks to go on before this thing meets FDA approval. That same idea needs to happen for AI, but also kind of after approval and really in perpetuity when it's being used, and not homogenously, but really in each setting in which it's being applied. I think some of the answer is also just that we are limited by the data that we have and the tools will be, and so it is really on the human effort to get more representation into trials, into the HR, into biobanks. And being a hematologic oncologist, there were a number of new specific indigenous biobanks, biobanks led, run, and kind of promoted by those physicians in different African countries, from Central and West Africa, that were, even amongst African populations, very much underrepresented in previous African American biobanks. And so I think there's a lot of those ideas that really need to get integrated into AI. There's a ethical framework called accountability for reasonableness, where essentially you need to come up with an ethical process, and that includes who's in the room making the decisions, kind of revisions to the process as they're happening, and understanding kind of what decisions are being made, how they're relevant to the actual whole population that the tool is going to be used in.
Yeah, I think the first place is understanding. Our patients have comments?
Yeah,
I think about this question, and then more broadly, how you think about this.
Yeah, I wanted to jump in from the clinical trial perspective. I mean, and just first to put in a plug for patients in general, I want wider inclusion criteria. This sometimes are life-saving or life-extending drugs that patients really need. So just saying, first of all, think about wider criteria. Second of all, I think the idea of, like you brought up the point, Dr. Hantel, about using AI to look through databases, find the right people quickly, but is it missing people? And I think that's a key thing. Like, don't let patients hear that, because they're going to get mad. But also to think about complementary methods, so not just relying on that. Maybe that's the first pass, the low-hanging fruit, so to speak. But there's other ways, like digital technologies are in the hands of patients these days, technologies like Outcomes for Me, where we actually have wider reach, and some patients that maybe aren't in your databases, to be able to go to them and say, here's a clinical trial, does it match for you? And really creating curated answers based off of their EHR, so that you have a supplemental way to make sure you're not missing by using the AI that's still like a little bit of a black box at this point.
Yeah. And I'll say, while I think there are biases and hallucinations to these tools for sure, that if you could improve upon the abysmal rates of clinical trial accrual today, it's likely that the rising tide lifts all boats. And so there may be biases in that tool, but likely it makes everyone's situation better if more people ultimately have clinical trials that they're eligible for that's identified. So I think as we sort of try to paint the picture of where we are today, right now it appears that for many things there's an overwhelming benefit of that opportunity. I know we have some questions over here on the far microphone.
Yeah, Marisa Weiss, breastcancer.org. Question for you about using AI to solve a clinical problem, which is patients are going into, with the 21st century access to their medical records, pathology report drops down, they need to understand what it means, it's really scary. How far away are we from AI helping people interpret their pathology report in real time when it drops, as well as the patient experience being through their patient portals, seeing the quality of our notes and the gibberish, the copied notes and all that? What's the opportunity there?
I'll just say, I think there's great opportunity for us to close the gap in what I like to call the information asymmetry between doctors and patients. It's a huge problem today, not only because pathology reports are difficult to read, but our therapeutic journeys for patients have become so much more complex. It requires a lot of education, and we don't do a great job at managing that. So I think actually digital healthcare and AI tools will improve upon that, because you could say, I'd like for you to explain the benefits and risks of adjuvant ribociclib in the language of a third grader, and get appropriate patient education for patients. You can say, I'd like for it to be in Spanish in Texas. That's important for me as a clinician. And those are things that I can then give to patients at the time of the visit, and immediately I'm going to be a better educator. So I think that a lot of those tools are there already. We need to prioritize their further development, and we need to be incorporating them into clinical practice. And I think we have some gaps there today. But again, I think even with the tools that are there today, patients immediately have access to more. Do you have other thoughts about that?
Yeah, I think that's an important application, and particularly if it can cut out the clinician role to some degree. Sometimes the patient is waiting for us to comment on the result that comes into their patient portal immediately. So if AI could be leveraged, I think the key there is making sure the language is in fact patient-centered, and having patient input on how those tools are developed would be very important.
Yeah, so our group is actually doing a couple studies on that very fact. We're trying to compare different summarizations of clinical notes into LaTeX and in other languages to kind of understand not only patient acceptability and accuracy and those kind of things, but also of the clinicians themselves and kind of how it would actually be incorporated, because I think there's also concern from clinicians that if you have your notes summarized potentially inaccurately, then you're leading a patient down the wrong path. And I will just make one note that patient advocates from the alliance that I've worked with have also had concern about a lot of the very critical results being released to them without kind of having that ability to speak to their physician right away. And I don't know if AI summarization and making it more understandable actually gets at that fundamental issue that some of the ACT has kind of inadvertently caused, and that it causes a lot of distress when it comes in on Sunday night at 3 a.m. and they're not going to be able to get a hold of their physician, but they have the new patient result thing coming up in their email. And I think we need to, and some hospitals have actually instituted kind of revisions within the scope of the law to be able to allow patients to really say, I want to wait for this CT scan result until I can talk to my physician about it. And that, I think, is also something that needs to be considered.
And I think it's hard because we don't want these tools to replace the role of the clinician ever, right? Really, we want it to extend our ability to be better. But the fact of the matter is today, we don't do a great job of spending a great deal of time on managing those things because most of us have a limited number of time with patients. We have really structured things that we're trying to get through in that time. And so we just don't have an unlimited amount of time to talk about all the things that are important for patients.
I just want to mention patients are doing it. Like they're like, I have a friend who he's an early adopter, but put all of his medical records into a public AI, which I think is crazy, but it returned back to him recommendations, some of which were good, some of which were contraindicated for his specific cancer type. So this is a risk. This is something that we really have to pay attention to. And even though we might want to put controls on it so it doesn't happen, some patients are going to take it into their own hands, and we have to be conscious of that.
Right. We have another question over here.
Yes, I'm a stegosaurus, so I have two concerns. One, of course, is the data dumps and the game of telephone that happens in medical records. And I'm concerned that AI is not going to really solve that problem. I can't even get the med list correct. The second concern is more a matter of creativity. In other words, if we are stuck with guidelines, they are by nature conservative, and they're based on good long-term outcome and therefore outdated by necessity. So if we are relying on what AI is collating, we're not going to have that creativity to think out of the box with a situation that may not completely fit with prior data.
Maybe that's true, but really remember that if you have clinical decision support that suggests choice architecture for clinicians, for nurses, for doctors, then it's in the doctor's purview to decide whether or not they want to preference the favored choice or whether they do need to do something novel and different.
I wish that were the case, but it's also insurance that sometimes makes those decisions.
Sometimes. I don't know, do you have an opinion about that?
Yeah, I mean, I think in terms of use of oncology clinical pathways, that's sort of one way in which technology is being used to drive treatment decision-making towards sort of guideline concordant care. But I don't think goal is to have zero off pathway
For sure.
utilization.
I would say 20% right now is like 10 to 20% is what we're thinking.
Yeah, that's gold standard now.
Yeah, so I think, again, using the technology as a support, but not the end-all, be-all for clinical decision-making is the key.
Because we all have reasons for warranted variation from guideline concordant care, right? Because patient care is complex. But I think that understanding that we don't want a lot of creativity in how we treat cancer patients, right? Generally speaking, probably most patients are best treated on guideline concordant care. Maybe everyone doesn't agree with that, but it's my opinion. That, in general, I think that it raises the bar to have choice architecture. Again, sort of how I think about this, there's this wonderful book, Nudge, that was in my slides with Cass Sunstein and Richard Thaler, talking about this choice architecture. And in my opinion, that's how AI will support clinician decisions best, because we want preferable choice architecture to help us make the right choices without being dogmatic.
Can I make a quick comment about this particular issue? It seems a little bit concerning to me that we're making comments about how we're going to practice in using these tools before we've used the tools to really look at our clinical practice guidelines. Perhaps that's where we should start. There is no question that many of us sitting in the room have had major issues with practice guidelines when we look at the patient sitting in front of us. So would it be possible that we could use this technology to start a little further back in how we develop our practice guidelines and then move that further into our clinics? I just worry a little bit about us relying on what is clearly biased in many ways, our clinical practice guidelines, and getting that incorporated into how we're designing our treatment plans when we haven't used the tool to optimize our clinical practice guidelines.
I think there's a lot of discussion in the guideline generators about that today.
Yeah, I know at least for ASCO, they're currently under a lot of discussions for how to optimize the guidelines, both from the standpoint of incorporating AI into it to check and kind of review those issues that you're talking about for prior ones, as well as to kind of how to make them more living documents that aren't, because we know that guidelines take a lot of effort to update, and kind of how that efficiency can be optimized.
And if I can just go back to how you framed this, which I think was really lovely, that really this is a tool, right? And as we've evolved to use new tools in medicine, especially ones that maybe sit behind a black box that we don't completely understand, there's a lot of sort of trepidation about our adoption of those tools, and we do need to understand them better and mitigate the risks and biases, hallucinations, all of those things for sure, but that really it's a tool, and no tool that we use is perfect.
So I have a question. How are you working the different ethnicities and races in with AI, and how do you tell the patient that this is what you're using? Because so many of them, young, medium, or old, have no clue.
Yeah, it's a great question, and I think that we don't know the right answer to that yet, but I think the first step is to understand the contributors to the models that we're using. If you are using a large language model, it's populated from data that is in clinical trials from SWOG or something else, you know that there's an underrepresentation of racial and ethnic minorities in those trials because that's well understood. And so I think that the best thing that we can do with all the tools that we use is to be candid about their limitations and hope to do better over time. Does our bioethicist have other opinions?
Yeah, I'm thinking, no, I completely agree with what you're saying. I'm thinking about it from kind of the opposite end of also how different groups are either being treated at institutions that may, because AI tools cost money, have less access to them, or themselves be less kind of literate with some of these tools as they're coming up, both from the standpoint of older adults that may not have grown up with these tools and communities that may have less access to them because of monetary means. And so I think it's both on the end of kind of the tools and their development and the data that's going into them, but also on the access side, and that, we think that there are great things these tools can do to provide expertise and expand the reach of oncologists and many professionals that are limited in supply and therefore are available to the affluent. But also, there's different risks that come with different groups essentially left behind.
I'm afraid that we are out of time, so thank you all, and thank you for our presenters and participants. Appreciate you.